Hello and welcome to this KNX system network topology and couplers webinar. So my name is Christophe Partoons, so the presenter as indicated on the slide also. And well, let's have a look first at the agenda. So I will in the first part talk about the couplers. So an overview of the couplers, so what kind of couplers do exist. The specific aspect of galvanic separation, the role of couplers, so the bus traffic optimization, so explain that to you as well. Concatenation, so what kind of concatenations are possible, so what kind of series or connections, if you want, can be made, but it will be clear when I get at that point, of course. Hop count, also some specific, very specific aspect of couplers in general. Link layer acknowledgement, also something very particular again. And then I will end with some more generic topics like the individual address and device types, cable distance, and power supplies. So this webinar is actually intended for those who are interested in, let's say, some background information on, let's say, in general, KNX network technology. So how to set up a network. So to go, so to say, beyond the line and the line segments. That is actually the purpose here. So I hope that it was also described as such before, or well understood by you, I mean before you actually subscribed for this webinar. Okay then, so let's have a look at the first topic. So here's the complete overview of the of couplers. So first of all, I need to make clear maybe that a coupler always has a primary side and a secondary side. So there are always two connections, right? And here we see listed on the top here horizontally the primary side. So that can be a connection for a twisted pair, for power line, radio frequency, or KNX IP. I only put short IP, but I mean of course KNX IP. Secondary, well, same thing. Well, it's also twisted pair, power line, radio frequency, and IP. So we can indeed have, theoretically, 16 combinations. And in the table, you can see that the red tag means that this isn't a coupler that actually exists. So this is a commercial product. Where we can see a green, when we see a green tag, it means this is a coupler that is considered meaningful. However, it's not commercialized. It doesn't exist. And a black little cross like this here means it is. This is a coupler considered not being meaningful. Well, let's start maybe with the last category, that is what is not meaningful. Well, indeed, one can say that everything where a radio frequency is on the primary side, that doesn't make much sense. What doesn't make much sense either is couplers where the IP medium is in the secondary. So that is actually also, so we can exclude already these combinations. So what is left here as in the category not meaningful is indeed a power line to power line coupler that indeed doesn't make any sense. There is no physical need for that because power line as such is already an open medium. So what's left is indeed so existing then is twisted pair to twisted pair. From twisted pair to power line, from twisted pair to radio frequency, and from IP to twisted pair. And then the rest, well, you can see for yourself what could be meaningful, but okay, not existing yet. So this, sorry, I went too fast. So here we see then the specific aspect of galvanic separation. So as you can see, indeed, if this is example given the primary side and this is the secondary side, we can indeed see that they are, excuse me, that they are indeed electrically not connected. So they are really separated from one another. They communicate via specific the specific technology of what is illustrated here. So with yeah, an LED and a photodiode. And this goes, of course, in both directions. It's not only from primary to secondary, but also the other way around. But it's just to illustrate the principle, and this is how we get indeed the electrical or the galvanic separation. And hence, indeed, two isolated circuits. Okay, what is actually the role of a coupler? Well, that's what I tried to illustrate here. So let's consider here this coupler, line coupler, where on the primary, where we see here the primary side and here the secondary side. Now, let's consider that on the primary side there is a collection of devices that are represented by a group address 1. And on the secondary side we have a number of devices that represent or that are represented by group address 1 and group address 2. Okay, so that means that in this case the filter table of the line coupler will contain one element or one entry, and that is group address 1. Why is that? Because that is because of the fact that group address 1 exists on both sides of the line coupler, so both on primary and on secondary side. That's why group address 1 is in the filter table. Group address 2 is not in the filter table because it only exists on the secondary side. So in practice or at runtime, this means that if a group address 1 telegram comes from the secondary side, that means that it will be copied or that it will propagate into the onto the other side. So the group address 1 telegram will appear also on the primary side now. It will be copied by the line coupler. Also the other way around, if the telegram, the group address 1 telegram would have come from the primary side, also then it will be copied onto or into the secondary side, right? If, however, this happens, so if there would be a group address 2 telegram coming from the secondary side, well, because of the filter table here, or let's say the filter table lacking group address 2, it means that it will stop here. It will not be copied into the primary side in this case. And that is actually the role of the couplers to prevent that telegrams would go around where they actually have no business or have no meaning. Okay, let's go through the existing couplers one by one now. So twisted pair to twisted pair, so where the primary side and the secondary side is twisted pair indeed. Well, then we see indeed here on a link layer level. Then, by the way, if you want to understand more about these layers, so for now I just add them as illustration. So I will not explain these layers, but if you want to know, you should also, you should also subscribe to another webinar which explains the communication stack of the KNX protocol, communication protocol. But for now, I just use it as illustration, so we can see on link layer level, indeed 3 separate elements, so to say. So that is a link layer specifically for the primary side, one for the secondary side, and in between there's the filter table. The couplers in this category are known as follows. So there are 3 types that we can distinguish. BC, so being the backbone coupler, so the twisted pair backbone coupler. LC is the twisted pair line coupler, and then there is also the line repeater, which is actually has nearly the same role as a line coupler, but not using the filter table. But don't worry about this now. I will explain it also later on. I will explain you the let's say the differences between all these three subtypes, if you want. Second type that exists is twisted pair to power line. So where power line is of course at the secondary side. This is called a media coupler. So also here for the communication stack we see separate separation for the link layer of twisted pair and the link layer of power line, and again a filter table in between. So also there in these media couplers filter tables exist. For a twisted pair to radio frequency, so secondary side radio frequency, it's also called a media coupler, and also the same principle applies. Also a filter table is on board here. And then there is IP to twisted pair, but so please note that now the primary side is IP and the secondary side is twisted pair, so that's different. And these devices are called KNX NAT IP couplers, or also short known as just IP coupler. And most of these KNX NAT IP couplers can also be used as an interface. So as an interface, that means it is so normally a KNX NAT IP coupler has, so to say, a runtime role. It is routing telegrams or routing frames. It's a synonym from IP to twisted pair and the other way around. So that's runtime. But they can also be used, well, most of them can also be used as an interface. So that means that is then for so-called tunneling, and tunneling is the how to say is the kind of communication that we need for one-to-one communication that we need in order to program devices. So that's configuration and has indeed as such nothing to do with runtime, of course. Okay, next aspect then, the concatenations. So sorry, I went too fast there. So I want to just give you an overview of what kind of combinations can be made. So if we would have a KNX installation that has a backbone line, well then we could put there the following devices. We could put a twisted pair to twisted pair coupler, which is then obviously a backbone coupler. We could also put there twisted pair power line, twisted pair radio frequency, but we can also put IP twisted pair, as you can see here. In the case of twisted pair, we have then furthermore three possible combinations. So that is first of all to also put a twisted pair in the main line, or in the main lines, of course. Then this is called a line coupler, and then within such a line we can also still put another twisted pair coupler, but then this is to be used as a repeater, right? If we would combine the twisted pair in the backbone, we can then still add example given, so here in the table, twisted pair power line, but then nothing anymore in the line itself. And the same goes for twisted pair to radio frequency. So the point is that if twisted pair is used, then still one more twisted pair coupler can be used, but that shall be used as a repeater. And for power line and radio frequency, it stops there, because there is no such thing as a power line repeater or a radio frequency repeater. And that means if you would, the cross actually means that ETS simply will not allow to add it to the project. Right? If we would put the twisted pair power line already in the backbone line, well then we cannot even create main lines for power line anymore, because or let's say we cannot better said, we have then a power line main line, but we cannot create a power line anymore. That is actually what it means. And the same is for radio frequency. The point being is of this entire overview is to point out that you need to be careful where you put the couplers in the topology, right? So again, if you would already put a twisted pair power line coupler in the backbone, this has consequences, as you can see here, right? It is also very easy to try. You can try it with ETS yourself, but then at least you understand why ETS is doing this. That's because of, let's say, yeah, actually, this is what the table represents. It represents the ETS behavior. Or it explains it. Then for IP twisted pair, well, what you can combine there is another, then, well, not another, so you start with IP TP in the backbone. You can put then twisted pair to twisted pair coupler. In that case, you can then also still add another twisted pair, but then it is a repeater. You would expect now, if a twisted pair is used on the main line, you would expect that twisted pair power line still could be used, because indeed physically or electrically this would be correct. I mean, no problem there. However, ETS does not allow it, and it's the same for radio frequency, by the way. This also goes then, so what we have seen here is the same principle that applies again. That is that IP to TP in the backbone combined with TP power line in the main line, well, that nothing can be added anymore. It stops there. Okay? So this is actually, yeah, the overview for an installation where couplers are used in the backbone. Now let's have a look when there's an installation where no backbone is used, so where it is actually limited to one area. Well, then the same principle applies. It's more or less the same as before, but then of course one step or one level lower. So a twisted pair can be combined with only twisted pair, but then as repeater. Also here, you would expect that a twisted pair power line and a twisted pair radio frequency, respectively, would be possible in that case, but that isn't. I mean, like electrically, it's all fine, but ETS will not allow it, right? Also here, when we put twisted pair power line or twisted pair radio frequency right in the main line, also there we can see that nothing further can be combined. And the same principle again also applies for IP twisted pair. So if the main line is IP, well, then you can add one more TP coupler, but as repeater. And also here you would expect that in the line of such an area, you can still add TP power line or TP radio frequency. Well, again, electrically it would be perfectly possible, but ETS will not allow it. You cannot commission such devices then. So these are the rules. So all summarized, so to say, in two tables. Now let's have a look at some live situation on the bus of what this actually all means. So suppose I have this KNX installation, so where I have here on the top the backbone, where there is a backbone coupler that will connect the backbone line to a main line of an area, where then the line coupler, of course, connects the line here to that main line, and on the other side we see the same thing. Within the line there is one line repeater in order to add another segment in the line here, in order to extend the capacity of that line. And we have here then two what I can call AND devices, so this very one here, and on the other end this one here. So, and now suppose that I want to do this. I want to send a message, a telegram, from this device, so being in this well, this very device here, to that other device on the other end of the installation, so to say. So what happens then is the following. So first of all, the device, the sender, will send, of course, a telegram, and this telegram has a so-called hop count on board. So that is a counter which is within the telegram. When the line repeater receives this telegram, it will copy this telegram into the into the other. So maybe I have to maybe restart again. So the line repeater will receive this telegram via its secondary line or connection, and it will then copy it into its primary. No filter table is used here because it's a line repeater. It's not supposed to check any group addresses whatsoever. So it will just copy it into the. Sorry, that was too fast. Sorry. So it will. So the line repeater will copy it. Without checking the group address. There's a filter table on board, but it's not applied, it's not used, right? So it will just copy it. What it will do, however, it will decrement the hop count. So it will go from 6 to 5, and then the same will happen with the line coupler. So also the line coupler will receive it via its secondary line, and will copy it into its line in its primary connection if the group address is in the filter table, which is in this case which is a fact in this case, so we can just assume that. So it means, okay, it will be copied to the main line, but also here with a decremented hop count again. So it will become 4. 5 becomes 4. Then from the backbone coupler to the backbone coupler, the same thing will happen. That will be, so it means the hop count is also decremented. From the backbone coupler to the other line coupler, same thing will happen. So hop count will be decremented, so 3 becomes 2. And then also same thing between the line coupler and the line repeater on the other side. So hop count 2 becomes hop count value 1. And then one more time this will happen between the line repeater and the other end device. So the hop count is then 0. So the telegram has reached its destination. So all fine. This is actually what happens when we send out a telegram, and when this telegram meets on its way line repeaters, line couplers, and backbone couplers. Theoretically, this is possible. I don't know if you I don't know if you understand what I mean. I mean this very green line here, this connection directly between the devices. Theoretically, you could also do it like that, but that is simply not allowed. So that is not correct. What is the reason for that? That is actually because of one of the KNX protocol principles, and that is that for any connection between two devices, there shall be only one path, right? Or concretely, it means that the KNX protocol actually foresees filtering and not routing. And that is actually the reason why this should not be done. Okay, so for maybe for a correct understanding, you might wonder, where is this hop count 6 coming from? Well, that is just how to say defined by the KNX specifications. So that is, there's no choice. There's nothing that can be changed about it. So the manufacturer has to set this to 6, and that's it. Otherwise, if it would be put to 8 example given or 7 even, it would not pass certification. Making it lower would be a bad idea anyway, because then your product is not compatible either. So you have to put it to 6. Because otherwise it will not pass certification. You will not get the KNX logo for your device. Okay, then a summary, maybe well, this slide. So we have seen indeed so source to destination, hop count, which is also known as the routing counter. Maybe you have seen that somewhere in other documentation. So it's actually the same thing. And as I explained, backbone couplers, line repeaters also decrement the hop count, and this in order to avoid endless telegram routing. So it should stop somewhere, and we have defined that, well, KNX has defined that to be 6. After 6 hops, it will stop. The telegram will not further propagate. That means at least that this is at runtime. So the maximum number of hops is 6 there, and if it becomes 0, then there is no further routing, as I just explained. For management, however, so when we are programming a device with ETS, well, then the hop count is put to 7. Only ETS is allowed to do that. Why 7? Because then we are sure that even if there would be some mistakes in the topology, even then the target device will be reached and will be programmed, because that is at that moment more important than the topology mistake, so to say. So that's why hop count 7 in that case is perfectly legal, so to say. Okay, couplers and link layer acknowledgement. This is also a very interesting aspect to understand what's going on there, because normally when we send out a telegram, let's say within a line, so let's take the example, so our line segment, if this device here would send a telegram to this device, there is always a link layer acknowledgement between them, just to confirm, yes, okay, I received it, you know. But what happens if devices are on the other side of the installation? What happens with these link layer acknowledgements? Well, let's look at this example. So where this device is the source and the other device is the destination, here on the other side. Well, first of all, there will be a link layer acknowledgement in this case, because they are not in the same line. So that means it will be different. So that first of all, the line coupler, the first line coupler, that is a MET, so to say, or a line repeater, that would also be the same principle, by the way. The link layer, the device will get this link layer acknowledgement from that line coupler. Okay. Then the line coupler actually, this line coupler here takes over the responsibility for the telegram and will send it to the backbone coupler. The backbone coupler will then, so it's then the backbone coupler that will send the acknowledgement. That means from that moment onwards, the backbone coupler, or this very backbone coupler here, will take over the responsibility, sends it to the other backbone coupler. Also that backbone coupler then will do the same thing, acknowledgement comes from there, and then the same happens between the other line coupler, so it also will send an acknowledgement, and then the line coupler will take care of the communication with the destination device. If, however, the device would send a negative acknowledgement, in that case link layer repetitions would be required. Well, those link layer repetitions come from that let's say that last line coupler, or the latest line coupler. So that means the repetition, sorry, will not come from the source device. So that is also, again, an aspect that we see of couplers where they help in optimizing bus traffic. So in case of repetitions, so the acknowledgements as such is already is of course, an optimization as such, but it's especially when repetitions would be required that we see, and again, an important role of couplers in regards of bus traffic optimization. So not only the filter tables, but also, yeah, the link layer acknowledgments and link layer repetitions. Then another aspect is, so for twisted pair topology is capacity. So what we see in a line segment is that there is actually theoretically indeed a maximum of 64 devices minus 1, because 1 is taken by the line coupler. So therefore 64 minus 1. If we want to extend the line then we need to do that with other line segments. And as you can see, this is also, and I didn't point it out yet, but as you can see, if you want to extend a line, you need to do that in parallel. You cannot make series connections here. So you have to put then line repeaters in series. In parallel, and then again, as such, you can add again 64 more devices minus 2, because the line repeater also again takes one connection here and one connection there. So on the primary and on the secondary, and this happens then per line repeater, per line segment that we add, and well, that's then in total the capacity of one line. Within the main line of the area, there's also a maximum of 64 devices, minus 16, because there in total we can have 15 line couplers, and so we have to count there the main connection and the secondary connection of the backbone couple. So that's why we have in total 16 here, 64 minus 16. 64 minus 15 in the line, in the backbone line, 15 because of the 15 backbone couplers, because of the primary side of the 15 backbone couplers. So that's how you calculate the capacity, the maximum capacity, or the capacity of a KNX installation for twisted pair. Now you would think, okay, we have line repeaters for lines. Why don't we have that for main lines and backbone lines then? Why can't we do this or this? Well, the reason is as follows. That is because if we would do that, we can no longer guarantee that telegrams, that all telegrams in an installation would reach their destination, because of this situation. It could be that we have 7, let's say more than 6 hops between 2 end devices, and therefore it's simply not allowed. That is the reason. So therefore the line repeaters are only allowed within lines, not in main lines and not in the backbone line. Couplers and visualization. So I have explained you the role of the line coupler in sense of bus traffic optimization. But there's another aspect to that, or there could be a problem because of that, and that is visualization. Visualization is typically installed on the highest level in the topology. So in most of the cases, that's of course the backbone line. However, the problem comes if we have this situation. So simplified example, of course. So again, group address 1 only in the primary side. On the primary side and the secondary side, but group address 2 only in the secondary side. And you can already guess, I think, what is the problem here. That is, if I want to also visualize group address 2, what can I do? Well, the first option is, of course, to manually add the filter table in ETS for this line coupler. But that is not a good solution. Why not? Because ETS will by next time you want to change something in the installation, it will automatically recreate, reconsider, let's say, the filter tables of the line couples, and will and the ETS will find out, hey, wait a moment, this line coupler shall not have group address 2. It will point out to the ETS user, you need to update this device, and if you forget about that group address 2, you probably just program the device. This is not good. So what is the solution? That is to find another way to add this group address 2 to the filter table, and that is by using a so-called dummy device. So what you do, not physically of course, but in the ETS project, you add just here a dummy device in the primary side. So in the backbone example given, you just add it there in the ETS project and just link this group address 2 to one of its objects. Although again, it's really doing nothing physically in the installation, but that's the way we can add it, let's say, permanently to the filter table of the line coupler. I mean, yeah, because of the ETS project. By the way, adding dummy devices is the best way, and there's even a specific ETS app that allows you to do so. Okay, next aspect, so the individual address, which is of course something I didn't even speak about it yet. But within a telegram, there are 2 octets foreseen for that. So whenever a device sends out a telegram, it contains an individual address, right? Now, the individual address, so the length of that is 2 octets. So here we see that it's so it has a high address and a low address, and the addresses, or these 2 octets, are encoded as follows. So in the high address, so the first most significant bits indicate the area of the device, and the other 4 bits of the high address indicate then the line where this device is installed, and the low address is then a device within that line. So that takes 8 bits. And now these are the rules here. So this is the summary of the rules. So first of all, it says the notation, so according to ETS, is A.L.D, so area, line, and then device. What is not allowed is that all 3, so area, line, and device, have the value 0. That is simply not allowed. If L and D are 0, so the line address and the device address are both 0, then this device is a backbone coupler. If, however, only D, so only the low address is 0, and L is not 0, then this is a line coupler. If A and L, so that means A and L, are both 0, then this device is a device that belongs to the backbone line. If, however, only L is 0 and A is not 0, well, then this is actually a device that is installed in the main line, in a main line. Another rule is that when D is 0, whenever D is 0, so the low address, well, then it's a coupler. That is that is the rule. When it's 0 is, or the other way around, only you can only use 0 for couplers. If the low address, so D, is not 0, well, then it's either a regular device or AND device or a line repeater. So this also means that a line repeater cannot have device address 0. It's simply not allowed. So these are the rules. Well, as maybe I didn't say it yet, but you will get tomorrow. You will get the slides or the slideshow. You will get them in your mailbox. So if this was a bit too cryptic or a bit too fast, well, don't worry about it. You will get the slide, and then you can check out at your own pace tomorrow. And together with my explanation, yeah, you will remember. By the way, the webinar will also be recorded and will also be added to the YouTube playlist, which you can find on our website. I will at the end of the webinar point out where you can find it. This very webinar is still not there yet because it's actually today the first time that I present it, but it will be added in the next coming days as a recording as well. But the slides you will get anyway tomorrow. Okay. The twisted pair topology and the device types then. So what we see here is, first of all, I want to indicate that, well, obviously this is the backbone line, but this has always the line address 00. For this line here, this is the main line 1.0. And here there's line.1. So that is actually the situation I have created, or that I want to achieve, where this is mainline 15.0 and I want this to be line 15.1. Well, what does it mean for devices? Well, first of all, here we see then, so here is actually the illustration of the rules that I have just explained to you. So that means indeed this very device here has address example given 001. The backbone coupler means then that it shall have address 100, and on the other end, so on the the right side here, this backbone coupler shall have address 1500. The device here in the main line has could have this address as an example, and the line coupler shall have this address, and on the other hand, on the other end or the other side here, we see something similar. So this would be the end device, or could be an end device. This has to be the address of the line coupler. And then this goes on, so line 1.1 means this could be an individual address of a device in that line, like this, on the other side as well, and so on. Line repeaters, so these are suggested, how to say, individual addresses for line repeaters. Does not need to be like that, but it's more yeah, structural in that way, but you can also just give the line repeater any other address, as long as the device address is not 0, and so on, and so on, and so on. I think this is clear. Then the other way around, so if we would have this situation, you could wonder, okay, what is then the addresses? What are then the addresses of the lines? So it's a bit the other way around. Well, then clearly it is like this and like this. So if you would like to see it from another point of view, if you want, and this line then, and then this is what we call area 1. This is what we call area 15. So we have 1 till, so 2, 3, 4, etc. till 15. So maximum 15 areas. However, there's also, out of completeness reasons, I also want to point out that there is also such a thing as area 0. So that is actually this here. So these are 15 additional line couplers added to the backbone line. So there are 15 backbone couplers in the backbone, but there can also be put additionally 15 line couplers to the backbone. And that's what happened here. Area 0 it's called. Okay, then some more practical, let's say, topics in order to end the webinar. So what we see here is a slide for sorry, distance and total cable length. So in the middle here we see the power supply of that line, and between the power supply and the latest, or not the latest, but the last end device, the distance shall not be more than 350 meters. And also what it says is that the distance between two end devices, so one on each end of the line here, or the line segment actually, shall be 700 meters. And the total length within one line segment is maximum 1000 meters. So the total cable length used within one line segment is 1000 meters. Topology structure. So this is actually anything is allowed. So star, tree, so everything except for ring, that is not allowed. So you cannot make you cannot close it, so to say. So for the rest, everything is possible with twisted pair. And then this is the last slide. So it is possible to have more than one power supply within a twisted pair line segment. So that is possible. However, be careful. You shall then, in that case, respect the minimal distance that is specified by the manufacturer of that of those power supply units. So indeed, as I said, that was the last slide. So first thing that I will do before I go to the Q&A section, so to say, or session better said, I want to first of all show you something, show you where you can find our webinars. Well, you probably know that. So first of all, here under webinars, you can then subscribe to all webinars of your of your interest. So example given, you have now followed telegrams and electronics, but it could also be interesting to follow communication stack tomorrow or next week or whenever it will appear, etc. So all these webinars will be repeated regularly. So that's the first thing. And second, here we will also offer recordings, and therefore you need to click here. So here, this is an YouTube playlist, and here you will then find all the recordings that are offered so far. This very webinar, again, this very webinar is not there yet, but it will be added in the next coming days also as a recording, or the next coming days, or well, maybe not. I cannot promise next coming days, but it would take maybe a bit more, but it will soon come. Okay, I think that is also clear. Now I would like to have a look at the Q&A. So just a moment, please. I need to just do some reading first. Just a moment, please. Maybe I just show you the questions. So the questions that you have forwarded to me. So here you can see, then can everybody read together with me. Will you speak about the physical wiring layout? I don't even understand the question, to be honest. I did address some physical wiring aspects, I think, at least. So I'm not sure about the question. I don't know if it's answered. Anyway, how do you define secondary and primary in this case? Well, if it's, let's say, that part that goes in the higher level of the topology, so example given, backbone obviously always goes in primary. So that is that's so according to the level in the topology. The difference between an IP coupler, an IP router, and an IP interface, the difference is that, well, the difference, so between a coupler and a router, these are synonyms. Coupler and router, synonym. Interface could be a feature of a coupler. Again, I said it actually during the webinar, a coupler always has indicates or implies or has the connotation of runtime, where interface always has the role of management, of configuring devices, right? Can we define the hop count? No, you cannot define that because that's defined by the manufacturer and it has to be put to 6, otherwise the device will not be certified. I explained that. The hop count is completely transparent to us. Yes, that's correct. You cannot. You can only see it in the monitor, and then yeah, you can check it via the monitor. I mean, then it's you can. Yeah, why not? You could do the exercise and see what happens indeed after 6 hop counts. After 6 hops, you will see that this specific value is put to 0. So you could check. A question, next question. Let's assume we have 60 participants on one side of the building and 60 on the other side. How to decide between one line of 120 participants and 2 lines with a line coupler? Well, first of all, the capacity, yeah, okay. That I would, yeah, I found that a very difficult question to answer. I think it depends on what future aspects that you have for this very installation. If you expect that it will be extended, it's maybe better to use a line coupler. I don't know. It also depends on, yeah, how are these 60 devices interworking, or let's say working together with the other 60 devices. If they are always all the time working together, then maybe it's better to put them in the same line. So yeah, I don't know. It depends, sir. It depends. So there are different aspects to be considered. So bus traffic is one of the aspects, I would say. Keep that within one line, I would say, yeah, and what will the future bring? You want to extend it, yes or no? If we don't add dummy device and we force the line to instead filter group address to route line to line main line and versa, it works as well. Yes, of course. If you add the group address manually, it has the same effect. Yeah, of course. Yeah. Do we get the video? Yes, I told you that. So, but you might need to be a bit patient though. But it will be added in the next coming. I can't promise days, but let's say one of the next coming weeks it will be there. Does the group address monitoring function of ETS work with the group address the group address monitoring function work with line repeater? Yes, wait, I need to think about this question. I don't see the relation between the monitor and a line repeater and a line coupler. These are just devices of a KNX installation. So, and the monitor works just for telegrams. It detects telegrams. So I would say yes. Yeah, I don't. Yeah. So for me, the answer is yes. How do we program filtering tables of a line coupler? Well, that is just by programming the line coupler. So in ETS, you add it to a line coupler is added to an ETS project, and its filter table is created on the fly. And whenever you program the line coupler, its filter table will also be programmed together with that. It's part of the configuration of a line coupler. As simple as that. You program it with ETS. The dummy ETS app where we can find it, well, you have to go via your My KNX account, and then you can check in the shop. So it's in the online shop. You can find it there. So KNX account, My KNX account, and yeah, that's all you need for that. When a project is commissioned, are you required to hand over the ETS project to the client, or is it property of the integrator? I would say that is actually pure one-to-one business, I would say. So that depends on what your customer wants. So these are rules not defined by us, by KNX association. So this is just, this is just, I would say this is just depends on the relation that you have with your customer. If an IP router is also an IP interface functional, is also or has also the IP interface and functionality, has the filter table effect to the IP interface or only to the routing? No, that's only the routing. So again, filter table is only applicable during it's only applied during runtime. So only for routing, not for the interface. Interface has a complete different role. That's for commissioning. Okay. On a KNX bus, what different network access devices exist? Typically require device address, which are idea location and so on, in the DB or any. Analyze the question. What different access devices exist?
Code 184.
No, I mean, any KNX device, so any KNX device that has a logo can be put in the network somewhere. That's it. So the requirement is that the device has a KNX logo. I would not say, unless I don't understand the question, then this is my answer. If interfaces are installed in the DB, is it required to install on every DB? If interfaces and the database, I don't even understand the question. Interfaces installed in the DB. Well, I can say, sir, that an interface could be. It's up to you, or up to your customer. If you can choose if you want to use the interface for that very particular installation, or even for that very particular line of the installation, that's up to you, or up to your customer. If you want to reuse it for other installations, that's up to you, completely up to you. So again, also here, unless I don't understand your question, this is my answer. What is the approximate number of devices in a project that makes sense to have in order to replace the backbone line for TP to IP? What is the approximate number of devices in a project that makes sense to have? Okay. I see what you mean. Well, it's not only the number of devices that defines it, it is really the bus traffic. The bus traffic. Yeah, I cannot answer that question. I would not know what is the criterion there. Yeah, sorry, this is really a question where I am simply not experienced enough. I do know the protocol quite well, but I don't have a real experience as an integrator. So I have to be honest on this. I simply can't answer. Sorry for sorry for that. Is the original ETS project required to maintain and troubleshoot the KNX installation after commissioning? Well, best of all, yes, of course, yeah. Otherwise, you have no idea what you're doing. What you see group addresses in flying around, or let's say telegrams with group addresses flying around, and you have no clue what they are. So sure, yeah, the project is definitely a big help there. So, and I mean, required? No, technically not. I mean, but it definitely is a big help. On a KNX bus, what different network access devices exist? So I didn't get the answer. I didn't get the question. Then you need to give me more specifics, sir. What different network access devices exist? Do they typically require device address? And where are the ideal locations to install them? In the DB, with DB you mean the database, I guess, or any arbitrary location. My question, how do you connect to the KNX network? Yeah, again, sir, I need more specifics. You would typically need, say, a USB interface, for instance. And yes, a USB interface would be a good idea to... how would you typically estimate bus traffic? Distribution board. I confused it with a database. Okay. Well, there are a number of interfaces. Well, there are actually two right now in support. That means indeed there's a USB interface, and there are KNX net IP interfaces. And that's it, sir. I mean, yeah, that is what you can use in order to program a KNX installation. IP, of course, means that you can also do it via internet, and for that you could, example given, also need, it would be possible that you need for that a VPN connection. So whatever happens on IP, that is then specifically IP. That has nothing to do as such with KNX. Is that then the answer that you were looking for? So again, summary, USB or IP, indeed. Well, I have the impression that then all questions are answered. Oh, there's one more apparently. The reason I'm asking is I have a client wanting to maintain and troubleshoot the KNX installation, but I cannot find any interface on the distribution board, and there is no ETS project over handed to the client. Ah, okay. Well, in that case, yeah, it could be that there is indeed no interface. Then you have to provide for one. That could be USB, example given. You just put it there locally. The ETS project, on the other, that is actually more, that is not a problem. The interface, that can easily be solved, but the project is definitely a problem there. Well, in that case, I recommend you to try to get it in any way, in some way, or to use, in worst case, the so-called reconstruction app. Yeah, in that way you can then reconstruct the ETS project. It's actually reverse engineering what you will do there. In that case, I'm kind of confused. I have limited experience in troubleshooting networks. Yeah, okay. That's at least honest, sir. So I would also be careful here. It seems to be like a big responsibility that you would take there. But of course, I cannot say more than that, I guess. The USB interface requires a device address, yes. As long as it's not 0. So 1.1. something, but not 0. Example given.
And before I conclude the webinar, I want to still present a few extra slides. And while doing that, I want to thank you for being here. I want to thank you for your attention, for considering KNX. And maybe we see one another in one of my future webinars. So thanks again, and goodbye.